expression for fringe width in interference or theory of interference of light. In this topic, we are going to find out the expression for fringe width. For that, firstly, we need to find out what are the positions for the maximum and the minimum. Okay, and in the previous topic, we have studied that the maximum will be obtained at the position where the path difference is integral multiple of wavelength, and minimum is obtained when where the position at the positions where the path difference is odd integral multiple of the wavelength. So it means firstly we need to find out the path difference. Now you can see that here these are the two slits, the two openings which act as a coherent source of light. When we kept here the source, the light imaging will be divided in such a way that these 2 points will act as a coherent source of light. And suppose the point P is a point on the screen MN at which we are going to find out the intensity. C is the point which is the center from this slit. Okay, and let this distance is x. This distance is x. Okay, and the distance between the source and the screen is capital D, and the distance between two slits is D. So basically what we are going to find out the path difference. Now what is that? That is BP minus AP. So it means whatever is the path difference, that will decide the position of maximum and minimum. So we can write here the path difference is equal to BP minus AP. Okay, now we will firstly find out this BP and AP in this triangle APE. Okay, this is, now you can see that here AB is equal to D, PC is equal to X, this is OA is equal to EC, so we can write this is D by 2 and this is also D by 2. Fine. Now we can find out this. Firstly, let us find out this BP in this triangle. In this triangle, this BP is acting as a hypotenuse, this is base, and this is perpendicular. So BP we can write here BP square is equal to BF square plus PF square. So writing this BF is D, this is D square plus PF is written as X plus D by 2. This is X plus D by 2 whole square. So BP we can write here BP is equal to root of D square plus X plus D by 2 whole square. Okay, so taking D common, so that will be 1 plus X plus D by 2 whole square upon D square raised to power 1 by 2. Right, or expanding this by binomial, we will be having this is D, this is 1 plus X plus D by 2 whole square upon this is 1 by 2 comes down, this is 2D square. So this is BP. Now similarly we can get the value of AP. Now AP in this triangle APE, AP can be written as AP is equal to root of this is AE square plus PE square. Now PE is X minus D by 2. So we'll write D square plus X minus D by 2 whole square. Okay, raised to power 1 by 2. Again taking D common, so we'll be having this is 1 plus X minus D by 2 whole square upon D square into raised to power 1 by 2. Expanding this by binomial, we will be having D, this is 1 plus X minus D by 2 whole square upon 2D square. Right, so this is AP. So we just had find out AP and DP, and we know that the path difference is given as BP minus AP. So writing the expressions for that, we will be having DP is D, this is 1 plus X plus D by 2, X plus D by 2 whole square upon 2D square, right? And in that case minus 1 minus X minus D by 2 whole square upon 2D square. So this one to one cancel out, and we are left with this d square. If we take d square common, so 1d is left only. So we'll be having 1 by 2d taken common. This is 1x plus d by 2 whole square minus x minus d by 2 whole square. Now opening it. If we open it, we will be having 1 by 2d. This is x square plus d by 2 whole square plus 2x d by 2, 2ab. Okay, so minus, this is x square plus d by 2, that will become minus because there is minus outside the bracket. This is minus d by 2 whole square, and this minus 2ab will become plus 2ab. So that will be plus 2x into d by 2. So these two terms will be cancelled out, and we are left with 1 by 2d. This is this 2 will also be cancelled out, this 2 also cancel out, that becomes 2xd. 2xd. This 2 will be cancelled out with this 2, and we are left with xd by capital D. So this is the path difference BP minus AP. Now this will decide either maximum is obtained or minimum is obtained. We have studied that in case of constructive interference, we have studied that the path difference should be integral multiple of lambda. So from here we can get x is equal to n lambda d by d. So where n is equal to 1, 2, 3, for n is equal to 1, x is equal to lambda d by d. For n is equal to 2, x is equal to 2 lambda d by d. And for n is equal to 3, x is equal to 3 lambda d by d, and so on. So these are the positions for constructive interference. Similarly, for destructive interference, the path difference x d by d should be odd integral multiple of lambda by 2. So accordingly we can write, from here we can get x is equal to 2n minus 1 lambda capital D by 2d. So n is equal to 1, so x is equal to, this is 2 minus 1, this is lambda d by 2d, and if you see, that becomes 1 by 2 lambda d by d, that is half of the position for first secondary maximum. Similarly, when n is equal to 2, x will become 2 to the 4 minus 1, this is 3 lambda d by t by 2, 3 by 2 lambda d by d, and n is equal to 3. Similarly, we will be having 5 lambda d by 2. So it means there will be one maximum and another will be minimum. Now similarly, we can get the expression for the fringe width. Let us consider the separation between the center of two bright fringes is calculated as beta, which is equal to xn minus xn minus 1. Okay, the difference between two bright fringes is given by, now xn is n lambda d by d minus, this is n minus 1 lambda d by d. So this n lambda d by d will cancel out, and we are left with only lambda d by d. So this is for the bright fringes. Similarly, we can find out the fringe width for the dark fringes. So here we can calculate beta is equal to that is xn dash minus xn minus 1 dash. Okay, now what is xn? Xn is 2n minus 1 lambda d by 2d minus, this is 2. Instead of n, we will put n minus 1 minus 1. This is lambda d by 2d. So when you solve it, you will get the same expression, that is lambda d by d. So clearly the fringe width for the bright and dark fringes are same. It means the fringes that we will obtain will always be having the equal width. And if we draw the pattern, we will be having, this is central maximum suppose, and again the fringes will be of equal width and equal brightness. We can also show that since intensity I is directly proportional to R, for maximum it is R square, which is A plus B whole square, which is constant. and I minimum, if we want to find out, that is a minus b whole square. And if a is equal to b, means if two waves which are superimposing are of same amplitude, then I minimum will be equal to 0. So 0 minimum and maximum will be having a plus b intensity.